Hey everyone, welcome back to 197 Concepts. In this video, I'm going to discuss with you to design a printed circuit board of the monostable multivibrator using the 555 timer. Now, in order to know what is a multivibrator, what is a monostable multivibrator, the pins that of a 555 timer, you can just check out the other video, which is the Astable Multivibrator. I have explained there all the pins and all the necessary graphs and all that we need for a monostable multivibrator and an Astable Multivibrator. So I will just share the link in the description. You can just go and watch there. In this circuit, I'm directly going to design the Astable, not Astable. I'm going to directly design the monostable multivibrator. For that, we just need a circuit, and I do have the circuit. It's somewhere. Let us just open Proteus, and we are going to use that particular circuit to design it again. Okay, in order to just show you the process completely. Monostable multivibrator, yeah. So this is the complete circuit, and let us discuss about this in a brief manner. Okay. So this is the complete circuit that we are going to design using the 555 timer. If you observe here, what I have used is I have used an LED diode. Okay. So when I push this button, this is a push button. This is specific push button. Okay. When I push this button, this capacitor, C1 capacitor is going to charge itself and discharge itself. And during this phase, the diode D1 is going to be turned on and turned off. What my target is, the 555 timer has to generate an output for a specific duration of time. Okay. Now, for that specific duration of time, you will find the calculations and all. You can do that. I'm just going to discuss with you the designing of this circuit, the method of designing the what we say the PCB. Okay. So this is the whole circuit. Without any delay, let's jump into the designing part. Okay. So yeah, this is the main circuit. I'm keeping it here. I'm just opening another project file, new project. And here browse. So on the desktop, I'm going to create a new folder called as Monostable. So select that folder, and the project name itself, what I'm going to give is Monostable. So without changing any of the template settings, I'm just going to click on next and then finally on the finish. So if you have observed the circuit, we just need 3 to 4 components. That the very first component is 555 timer. Then we need a resistor. Okay. Then we need a capacitor. Then we need a push button, or else you can just go for you can use this one, or else you can simply go for a switch, switch. But within that switch, you should select the momentary action. Okay. So yes, we can select this one also. And what are the other components? Yeah, that's it. Those are the components. Okay. So just minimize it. Okay. Click on OK. Now place the components. So 555 timer. The very first thing that I'm going to place is a 555 timer. And to this 555 timer, I need a capacitor that must be placed right here. Another one just right here. Okay. R1 and R2. So this one is connected to this fifth pin, the control voltage pin, resistor, It's placed here. R1 is placed here. It's yes R1 or 2, whatever it is. I just need the hierarchy to be same, so that's why I'm just being selective. Then this pin, and these are the connections that I'm doing. So R2 is connected with C2, then R2 is connected with C2, and R1 is connected to the power supply. This resistor and this resistor are connected with the power supplies, and this one is grounded. It's the easiest circuit. So yes, it's going to be connected like this, and this part is going to be connected like this, and this one like this. Finally, this has to go to the threshold voltage. Keep in mind there's a node here. These two wires, this CV pin number 5 with C1 capacitor C1 are overlapping. This wire is overlapping with the trigger pin wire and R1 wire. Okay, so there's no node here. And finally connecting the ground to the circuit. There are these three pins. So these three pins are definitely they're shorted. So C6 pin and C7 pin, they are shorted between the resistor and capacitor. Okay, that's it. And yes, we need power supply, ground. So ground is connected here, and then we need the power. Okay, and then yes, we need a switch in order to give a negative pulse for triggering the 555 timing. Okay, if you observe this switch here, it's very different work. It operates very differently. You just click it and you hold it in order to complete the circuit. If you leave the mouse, it's going to open it on its own. So I have just made a click. So it's just going to contact with the switch, and then it's going to disconnect switch again. Okay. Now finally, what we need is we need an oscilloscope. Yeah, we do have an LED here. I have not selected the LED. So LED, not the generic one. We need something to display. Okay. So I'm going with white color or yellow. I will go with yellow. Yellow is much brighter and it's easily visible. So yes, I'm going to connect this here. And in order to control this, in order to protect this LED from burning out, I am going to place a resistor here. Okay, and the output pin of 555 timer connected to the resistor. This resistor is connected to the diode, and the other terminal of diode is connected to ground. So these are the connections. Now if you check the values, so that's 10, that's 1K, and 0.01 and 3 millifarads. So 0.01 microfarads. Of course, I forward the F. That's 10K. It's just 1K, and this is 3 millifarads. Okay. Now we need the oscilloscope. Of course, we need this configuration of power rail, and yeah, configure it, not the ground. VCC, it's for 5 volts. I'm going to change this to 12 volts. Okay. This 555 timer is going to accept from 5 to 15 volts. I have just kept a margin of 12 volts. That's your wish. Then what else do you have to change? Yeah, this one. This has to be changed to 220 ohms. If you keep this value R3 values very high, then your diode is not going to be turned on. Okay, now that's it. Simply I'm just going to run this circuit, and if you see initially the diode just it blinked once. That's the initialization stage, and then it's in turn off position. Now when I just click on this switch, the LED is going to be turned on for some moment. During that moment, this capacitor is going to be charged. So after reaching a specific its peak value, the diode is going to be turned off. So see here again, I'm just going to click it once. So I'm just giving a negative trigger, and then after some duration, immediately after clicking here, the LED is going to turn on, and after reaching a specific period of time, it's going to be turned off. So why is it going to be turned off means the capacitor C2, that means the C 3 millifarad capacitor, it has been completely charged and it is not able to hold any more charge. So that's why it's going to change back to logic 0. Now in between that state, if how many times, regardless of how many times I'm going to click it, it's going to stay for a specific duration. Okay, so that's the thing. And in order to change that cycle, what I'm going to do is I'm simply going to reduce this to, let us say, 1 microfarads, and I'm going to run this again. Now, when I click here, see, this is completely instant. Okay, so this is completely instant. You cannot, so 1 microfarads is going to need very less time to reach its peak value. So again, what I have is, let us try with 1 milli so that I can show you the difference. Now, yeah, it's going to stay, but for a short duration. So at uh, 6 seconds, the LED is turned off. So it took something like 1.5 seconds or so for the capacitor to completely charge and discharge. If I keep this to 3 millifarads, so yeah, 2 it take nearly 2 seconds or 3 seconds to reach the charging and discharging of the capacitor. Okay. Now, if you want to check the graphs of this, just go into the virtual instruments mode, click on oscilloscope, check it, place it here. Now, pin number 3 should be connected to pin number C of oscilloscope. The pin B will be connected to this part, as this shows the charging and discharging of this capacitor. And finally, we need the trigger pulse, which I'm going to connect it to the switch here. Okay. Now, when I run this simulation, check the graphs. Okay. When I click here, okay, I need to reduce this. I'm going to keep it minimum. Okay. Now, when I close this switch, yeah, I got this some value, and then immediately after shutting it down, I have got it. Now, so this is not giving me a trigger pulse. In order to get the trigger pulse, let me check this one. Okay, okay, this pin has to be checked in. Okay, yeah, yeah, that is giving me a trigger pulse. Okay, so I'm going to get a continuous signal. Now this is a trigger pulse, and observe here. Oh yeah, I have the complete cycle here now. Just I need to expand this. Yeah, if you observe here, so the circuit is going to the circuit. Yeah, yeah. If you okay, this is missing out. No, this is missing out. I need to keep it at 200. I need to expand this more. So the oscilloscope is much more easily visible. Triggering it. Right. This will show me the complete graph. Why is the D pin coming out? I have not connected anything to D channel, so why is it giving me the output? It has just shifted to logic state 1. Okay. So this is the overall graph. If you observe here, it is at the positive, some positive voltage. So that will be 12 volts, of course, 12 volts DC. When I connect the switch for a moment, it's going to drop down and then it's going back to its normal phase. So this is the charging cycle. So 3 millifarads, it doesn't give a huge charge. It's just a very small, minute change. And what you have to observe is when the capacitor is charging, my LEDs has been gone to state 1. Of course, due to its load and all, it's not going to stay at logic 1. It's definitely going to reduce its value. So it's going to come back to 0, but that value is again going to drop below 0 due to some practical issues. And then it's coming back to the logic 0. Okay. So this is the real world graphs. You cannot, ideally, it should come back to logic 1. It should not drop like this also. It should not drop in this manner also. It has to stay at logic 1. Okay, ideally, but that's not possible in all the cases. So that's the reason you're getting a different gap. Now if I change this value to say 1 millifarads, now if I run this again, and yeah, I need this to be large enough, and yeah, the moment, see, the graph has been changed. So the duration is changed. Okay, if I give it multiple times, if I give the trigger multiple times, okay, what you can observe this, irrespective of my multiple times triggering, once the capacitor starts to charge, it's going to complete its cycle. It's going to reach its peak value and then it's going to drop to 0. Then at this moment, if you have a negative trigger, again it's going to start its charging cycle. Okay, that's the points you have to observe here. So that's the whole circuit. And let's go for the PCB design. Okay, so for that, what I have to do is I have to do some changes, minor changes. So what I need is 2 pin headers. That's a 3 pin, 2 pin headers. Okay, so place them. I need 4 3 pin headers. One, yeah, one right here, one right here, and then another here. So let us place this here also. The very first thing, I need to connect all the grounds. Okay, so one jumper is used for checking the capacitor's charging and discharging cycle. One capacitor is used to check the output of this diode. So basically, we are checking with the help of diode, we are checking that the capacitor, that the 555 timer is able to turn on the diode for a set duration or not. Okay, that's our main target. If you want the graphs, you can use this. If you don't need, just skip this part. Okay, yeah, and here we have to configure. We have to go for terminal 1, terminals mode, and select this J1 for power and ground, so that you get the mains, so you can give the power supply and all. So yeah, here what I'm going to write is this one, I'm going to rename it as out, and this one I'm going to name it as cap, and then this pin, yeah, it's a trigger pin. Okay, so it has to go towards this, there, to the trigger pin. What I'm going to name this as TRIGG. Okay, that's the trigger output. Okay, simply now what I'm going to do is I'm going to go into the PCB mode, and yeah, first thing that I'm going to do is place the box so that I can place all the components. I've placed it here, and if I go for the component mode, I hope my LED is having the LED is not having a package. Okay, Let's go for auto placer, and I'm going to place all the components. So the D1 and the switch are pending. Okay, so diode and the switch are pending. So I have to assign them the footprints. Since I'm not having the packages of those, it's not going to show me here. I'm going back to the schematic, and I'm going to right click on the component for which I'm going to assign the package or footprint, then selecting the package tools and searching for the existing one. So let us see if I have switch dip 4 push button I have built in. So yeah, if I have the push button itself, so delete this one, search for the component, and I'm going to use push button itself. Okay, so push button, and then going into connecting it to ground. Now, so if you observed here, even this push button is not having a PCB. Okay, push button is also not having a PCB layout. For this, what I'm going to do is I'm just right clicking on it, packaging tools, and click on add. Here I need to type button. So yeah, push button, mounting push button, round 4 terminals and 3 terminals. So I'm going to select this 4 terminals one, click on OK, and the pin number one. Okay, so pin number one, I'm going to connect it to one, and this one to the two. Okay, and assign package. So user DVC. That's it. Yes, and now when I go again for push button, I will be having two different push buttons. This is the active and this is the user defined. So user defined is having a PCB preview. Okay, and in the same way, my LED is not having an PCB layout. So PC footprint, going for right clicking on it and going for packaging tools, add. I'm just going to search for LED. Okay, so that's it. Our LED will be of the same dimensions. So I'm going to select this. The others are of different. Okay, so I'm just going to select the basic one, clicking it on OK. And the anode pin has to be the first pin itself and the second pin itself. So it's not going to take the names. One and two. Okay, so cathode is the second pin and this is the first pin. So assign the package. Pin number one specified for pin A was not found on the PCB package. So this has to be resemblance with this name. So anode has to be mapped with A and cathode has to be mapped with K. Okay. Enter, assign package, save it in the user DVC. Yes. And now when I go for PCB layout, see I have the diode D1, but yeah, push button. The push button is not showing. Why is that? I have used it, right? So PCB layout. Okay, let's place the diode. Completed. Push button. It's not showing me. Okay, what if I name this one? Edit properties. Exclude from PCB layout. It's telling me to exclude from PCB layout, which I cannot do. Okay, so click on it. Now when you go for PCB layout, components, still it's not showing. Maybe we have to rename this. Edit properties, part references, B1. Okay, now it's showing B1. So like that, place there. And when I check the PCB layout, so yeah, that's a push button. You're just going to press on it. Okay, so that's a push button. Now what we have to do is we have to just place the components in their appropriate positions and route them. So the very first thing is select this one. Okay, and select this one, rotate it in clockwise direction, and you have to place it somewhere there. The other thing is, let's go with the schematic. The R2 and C2 has to be placed up and down. So yes, search for this. This is for LED, right? So drag the component, no, not that one. Drag this component and place it somewhere here. Then R1 goes somewhere at the input side, and R2, this one goes somewhere to this side with C2. So yes, C2 should be placed somewhere here, and C1 goes somewhere here. Okay. So if we connect these first, then I'm going to think, or I'm going to uh, place the output parts. Okay. So yes, this has to be anti-clockwise. Yeah, power pins. Means I'm going to keep it somewhere aside. Okay. Means I'm going to place it somewhere here. Anti-clockwise. Mm, yes, that's the basic things that I need. I'm just going to connect the circuits one by one so that later I can get a clear of should I move the components and all or not. Okay. Oh, no, no, no. Drag the component, place it a little bit more on the top side. Mm, rotate it for 180 degrees. Drag the object. No, not that one. Okay. Mm, yeah, this is for LED, right? This is for checking the output. So this should be somewhere with the output. I will place right right here for checking the output. Okay. So along with this, I should have this one also along with the LED. Okay. So LED is connected to anode. Just keep it like this and rotate it in a anti-clockwise direction. So it's going to be placed like this, or else you can keep the component right here. Okay. Now the pin number 3 has to go to that way. So this part will cause me a short circuit. Okay. Let's do the connections first. We will change it accordingly when we go into it. Okay. So this pin is the ground pin. So I need the power supply pin. First of all, connecting the power supply to this part because that is shorted, right? And this pin will be connected to this wire. Okay. And 6 or 7 are shorted. So yes, that's a direct connection. You can go that way. And pin number 7. What if I move this a little bit down? Or else, yeah, we will do it this way. So pin number 2. And if I can move this component much closer, I don't believe there's a connection between, no, there's no, yeah, I was searching if there was a connection somewhere here. So it's better if we just delete this. We go for the component mode or selection mode, select this one, and if we keep it somewhere like this, okay, and move this towards the top. So yeah. connected. Now this is going to be straight to this wire, and this thing I'm going to move it much closer to this second pin so that I can use this third pin routing here. Okay, so path, and these two are connected, right? Then yeah, those are the outputs. I will check those later. Pin number 2 is connected to the ground. So yeah, grounds I can do the connections later. Very first thing that I need to do is I need to connect this to the ground, and the pin number 1 is connected to the ground. Yes. So pin number 1 is connected to the ground, and pin number 2 is connected to the threshold pin or trigger pin. It's connected to the trigger pin. So yes, that's the connection. And same, the trigger pin is connected to the pin number 2, or the resistor is also shorted, right? No, the resistor is shorted to the power supply, not to the trigger pin. Mm, yeah, let me just connect this ground first. This is it. Okay, he's telling me to connect this uh, power supply pin. Okay. No, if I move the resistor towards the top also, that's going to make a problem for me, as it's going to get short between these lines. Just let me try this once. If I keep it in this way, or if I keep it here, okay, this will be connected to the power pin here, no doubt in that. And yeah, from here it's going to be connected to this pin. So this pin is going to be connected here. The fourth pin, should be connected to the power supply. Okay, this is direct. You can use it. We can reroute the pin number 3. Now the ground pin. What I'm going to do is I'm just going to reroute it like this to this pin. Okay, so it has completed that route. Now pin number 5, pin number 3 has to be connected there. The C1 and C2 has to be connected to the ground. Okay, now the tricky part, these connections. The capacitor output. Let us keep those in a line, specific line, so that we can see the outputs properly. So the very first thing is the second thing is the capacitor output. The very first thing is the trigger output that needs to be placed somewhere here, and finally the LED output. Okay, so I need to connect these grounds. Simply what I'm going to do is I'm just going to delete this one also, and I'm going to move this capacitor a little bit near to these, and now go to the path, and yes, this is the cathode, so I'm going to create a separate ground line that's going to run throughout the board and connect right there. Okay, and all these components I'm just going to connect. Oh no, I don't need the top copper, I need the bottom copper. That's it. No, it has not connected. That's one ground. That's the another ground. That's another ground. And finally, that's the another ground. Okay. So yes, this capacitor is also connected to ground. So we can directly use this, or we can directly place this onto the ground itself. Ground wire. Okay. Now I have a complicated task here. Hmm. Yeah. See, this pin number 2 has to be connected to the trigger output, but my problem here is I'm getting an overlap condition here. So for that, what I'm going to do is I'm simply deleting this ground. I'm going to move this capacitor to this place here. And what I'm going to do is I'm going to rotate it in anti-clockwise direction so that now when I place the wires, those are on a perfect straight line. It has to be connected to ground. So I'm going to connect it this way. That's it. This clears me the path for this pin number 2 also, which I can directly take it from here also. Okay. So yeah, trigger pin. I'm going to, instead of going that way, I'm just going to connect it onto this junction point. That's it. Okay. So from there, I'm going to check the output for the trigger pulse. For the capacitor output, what I am going to do is I am going to use this, and yeah, I'm going to directly drop it down like that. Okay, and yeah, I do have to connect these two also. So simply I'm going to drop it straight and make a turn like this. Now the final connections are just the pin number 3 and the pin number 4. So directly connect these two. So no doubt for this I'm going to route it. Yeah, we get a problem here. So instead of going from here, okay. So the only way is to get through this. And pass it from here and to this part. Okay, so yes, let's route it starting from there. Get a round about, get a circle here, and then yeah, route it. Yeah, it's crossing from there, and finally to this part. Okay, so that's a complete PCB. And when you take a look in the 3D view, so these are the all the components. Okay, and when you check on the bottom side, you have all the wirings and all. Okay, so yeah, that's the complete designing of the triple five timer for monostable circuit. And by using these three header pins, you are going to check the trigger, capacitor charging and discharging, and the final output of the LED. Okay, and these are the main pins that we are using to give the ground and power supply to the whole circuit. So that's it in this video. I hope you have understood the designing part and the complete circuit and all. So that's it in this video. See you in the next video. Thank you.